Hello, welcome back to Cognitivology. If you've come this far, you're at least curious about what it is that Cognitivology has to say. First of all, I'd like to let you know that this online webinar is an informal presentation of Cognitivology. Our formal presentation is actually in writing in the form of two books. The first one is called Connecting the Dots, and it's a book that has a subtitle explaining the strategies and reasons for a cognitively correct way to speak with preschoolers. The second book is called The Dots Connected, and it's a 300-page book that comes also with a supplemental workbook. But it's a prose book mostly, and the subtitle of this book deals with the strategies and reasons of intuitive development. Essentially, the subtitle of The Dots Connected is, what does childhood have to do with adulthood? Plus, what is intuition's role in fulfilling the potential, the total potential of the human brain and the unlimited potential of the human mind. And this book goes into great detail. So obviously, all of the details of this book would be hard to cover in one informal presentation. But we did promise to give you a session where you could get some continuing education information that would be applicable to the way that you teach, especially young children, and also to the way that you think about yourself in your own job, especially when speaking to children and seeing them as how they would be operating in the future. In other words, seeing your work in the future in the way that children have been cultivated to think in the best ways possible according to their abilities based on the way that you have helped to nurture and teach them. So the first thing that we want to go over in this introductory section is to just review what the three main topics of this webinar really entail. And of course, the first one, as explained in our infomercial, and if you missed our infomercial, I encourage you to go back and listen to it. It's fast and it's detailed and it talks a lot about basic science and math, but it works as a very good precursor to one of the main concepts that we really want to concentrate on in terms of reforming early education, because early education is the foundation of all subsequent stages of learning and cognitive development. So of course, Dots Connected and Cognitivology in general is concerned with three or four main things. And all of these things are synonymous in nature. So the first one, of course, is how is childhood always affecting adulthood? But more specifically, how does child brain development affect adult brain operations or adult intelligence and behavior applications? And specifically, we want to look at how preschool development affects the development of the prefrontal cortex during the teen years. Now, there's nothing out there explaining any of these things. And if there is, I urge you to find it if you know anything about it, and please contact us and let us know. But from our investigations, we've been unable to find anything that distinctly and rigorously and neuroscientifically connects the years of early development with the adult stages of intelligence and behavior applications. And in particular, we are concerned with what role intuition plays in helping to develop the whole potential of the human brain and the unlimited potential of the human mind. Now, we should go over intuition a little bit. A lot of people think that intuition is just this sort of psychic, hocus pocus, mysterious characteristic. And in some ways, maybe it is. In a lot of ways, I would say that there is a certain distinct characteristic of intuition that portrays itself in that sense. But that's because it covers so many forms of knowledge and information. Essentially, the most basic definition for intuition is the connection between basic and diverse pieces of knowledge and information. In adulthood, the practical applications of intuition is the ability to instantly connect pieces of knowledge and information, or process new knowledge and information, or new patterns of knowledge and information, and being able to attach it to our already open-ended patterns of knowledge and information that we use. So that is the practical application of adult intuition. But then it entails a lot more that is relative to the way that we use the foremost and advanced process of adult intelligence skills, meaning the areas of the front of our brain, the frontal lobes, and especially the prefrontal cortex that exercises certain abilities. We want to be able to connect how preschool development, or intuitive preschool development, and cognitive preschool development distinctly affects the cognitive and intuitive development of the prefrontal cortex during the teen years. So these two have to be connected. And lastly, one of the most important things that we need to explain from us here at Cognitivology is that we believe that more than 20% of brain potential needs to be tapped. So if we're running on 20% of brain potential, or 10% or 30%, depending on which expert you ask, then, and if our world is operating according to the processes and characteristics of that 20% of potential, unless we are challenging this 20%, unless we are challenging that 80% to become unleashed and untapped, then according to the way the world is operating and all the endeavors of life, then this is surely the way that we should continue to operate. If the 20% gives us the endeavors and livelihoods that come with war and famine and strife and adversity, then what do we need to do to change? There's nothing that we need to do. So somehow our intentions and our desires to see peace and harmony in the world has something to do with that 80% of locked down brain potential. And those are things that we need to connect. So when we could come to terms with the connection between that, what we really want for this world, and that locked down 80%, when we can connect childhood brain development with adult brain applications, then we're talking about changing the way the world operates. But the bottom line from Cognitivology is this: if we continue to do the same thing that we've always done, and we're operating on 20% of brain potential, or 20% of what real, true knowledge and information possibilities are, then obviously the definitions that we have for all these things are inconsistent or inefficient with what it is that we really want to accomplish. At Cognitivology, we actually define these things as being so poorly defined that they are disconnected from other aspects of humanity and the endeavors that we embark upon. And so because they are so disparately disconnected, then we can never dispel the disconnection so that we can actually create a connection between them. So one of the main goals of Cognitivology is to redefine all of the characteristics of human intelligence and human behavior so that they could be connected. But one of the main goals under that topic, or the subtopic under that topic, is that all skills of behavior as well as intelligence have to be redefined or properly defined according to cognitive processing, according to our cognitive skills and our cognitive potential. If these skills are meant to be integrated and work harmoniously together, then we need to find ways to redefine all of the skills of behavior and intelligence so that they can be connected together. Well, this is the end of our introduction. Please stay tuned so that we can introduce you to part 1. Thank you. Hi, this is part 1 of our informal presentation of cognitivology, but I'd like to go headstrong into the bulk of what all of this information really means, because we did promise to teach you something new. Here in front of me, I have a copy of an article produced in Time magazine, where it was published earlier in March of this year, I believe, 2012. It is written by senior science writer Jeffrey Kluger. And the title of the article, as you can see, is Getting to Know the Science of Building Willpower. Before we go on, one of the things I'd like to lay out very distinctly are what are the skills of the prefrontal areas of the brain. Remember, what we want to distinctly define in cognitivology is that childhood development is connected to adult development, that preschool development is distinctly connected to the development of the prefrontal cortex. So the childhood brain is distinctly connected to adult brain intelligence and behavior applications. We want to distinctly define intelligence and behavior applications, or intelligence and behavior skills, as both being subject to cognitive processing. We think of intelligence as being just in cognitive processing and intelligent cognitive processing, but behavior skills must also be defined as cognitive processes. Another thing, before we go further, we understand that for many adults, self-improvement skills have often entailed changing language. Language in adult self-improvement has often entailed eliminating words such as should, must, and have to. But these are words that are verbs or verb helpers or verb modifiers. They're words that the brain can actually process. It's negated verbs that the brain is unable to process. But we go through the reasons and strategies about this more distinctly in our literature, so we do hope that you'll have a look at it. In this particular article, once again titled Getting to Know the Science of Building Willpower, it is written by senior science writer Jeffrey Kluger, and in it they essentially outline that willpower is a part of is exercised by a part of the brain in the frontal areas, or the prefrontal areas. And these areas conduct and orchestrate specific skills that are relative to a fully matured adult brain. We can actually give each of these skills names, and some of them you'd be very familiar with, of course, but you may have thought that these skills were just sort of inborn or intellectual or something that may have been learned in higher education. But we all have the potential to master, to intuitively master the skills of the prefrontal cortex. That is the particular area that is connected with our ability and our hope to tap into that 80% of latent brain potential. Those skills are willpower, common sense, critical thinking, hypothesizing, theorizing, intuitive reasoning, quantum processing, foresight, judgment, precognition, computational thinking, and decision-making skills. These are the skills that are exercised by our prefrontal cortex in conjunction with our brain's hardwired system. So in other words, when we exercise those skills, when we have intuitively mastered those skills, it would be based on a full development of the brain's hardwired system, or its modem, which is based on the characteristics of optimism and compassion. Now, we'll be defining those in our next section. We'll be distinctly defining those, but for now, I would like to just go over this particular article. In this article, Getting to Know the Science of Building Willpower, it says here in this particular part, and I quote Mr. Jeffrey Kluger from Time magazine, saying, if willpower is elusive, it's also trainable and cultivatable. Now remember, willpower is synonymous with these other skills of common sense, critical thinking, computational thinking, intuitive reasoning, decision making. These are all interchangeable skills conducted by the prefrontal cortex. But the prefrontal cortex does depend on certain fundamental skills, which I will explain in a minute, because I would like to explain how the prefrontal cortex is essentially connected originally or based in the preschool stage of development. So there's three ways of explaining that: frontwards, backwards, and according to the basic rules of intuition. To get back to this article, however, it says here that willpower is trainable and cultivatable. But the most important statement that is made in this article, and I urge you to have a look at it in case you think that I'm taking any of it out of context, it says that the simple truth is that the brain evolved from back to front. And if you review our infomercial, that was also mentioned. Our brain evolved over thousands of years from back to front. But in our individual lifetimes, our brains also develop from back to front. So unless there's some kind of a barrier where between the back and the front that they're never supposed to be connected, or we get to trade in our childhood brains for an adult brains, then there has to be a connection, a relative, working, harmonious, interconnecting process between how the back of the brain works and the front of the brain. In other words, the back of the brain develops in our early development. It's concerned mostly with emotional intelligence development and our desires. The front of the brain is the part of our brain that develops its reasoning skills and all those other skills of willpower and common sense that we mentioned. So it conducts and oversees how we use all of our acquired intelligence and also our emotional intelligence capabilities, our feelings, our desires, our impulses. So there's supposed to be a coordination there, a logical, common sense, beneficial, advantageous coordination that supports and sustains the use of our abilities to our best ability or our intuitively refined abilities, but consistent with the brain's hardwired system for compassion and optimism. This is a synthesis of how brain development is really supposed to work. So it says here that the back of the brain is the wanting part, which I already explained. And the front of the brain, here it explains it as the restraint part. I explain it as the coordinating part, because the wanting part, which is synonymous with your desires and your emotions, these aspects of early development are the seeds of our abilities. So emotions have to be treated as abilities, and that is how we actually connect the back of the brain with the front of the brain, because we treat the front of the brain or the skills of the front of the brain as abilities, but we tend to treat the back of the brain or the emotions and desires as something that is inconsistent with abilities, but they are the seeds of our abilities, so they also have to be treated. So that is the fundamental connection. But here it says the back is the wanting part and the front is the restraint part. And they're both with us all of the time, of course, because we have to use all of our brain all of the time, which is what we're supposed to do. The goal of a rising band of willpower researchers is to make peace between the back of the brain and the front of the brain. Well, that is what we have done here at Cognitivology. We have made peace with the back of the brain and the front of the brain, and that is why we can make also the claims that there is nothing else out there explaining the exact connection between the back of the brain and the front of the brain. So, to explain the connection that we have a back of a brain and a front of a brain that's supposed to work together, there is 3 basic ways to explain it. Normally, we never think of adulthood as really being connected to childhood. We say, yes, it's affected us, but we never understand exactly why and how. If we ask somebody, if I asked you or you asked me, please explain your first impressions about the connection between soil and plants. You would be able to explain that to me, or about food and your digestive system, or about cars and gasoline, or about the sun and light. And we would be able to give a basic explanation of these things. But if you ask the average person, please explain the connection or relationship between the back of the brain and the front of the brain, even neuroscientists are lost. And we each own a brain. So, we've never owned the sun or a piece of its light. We get to use it, but we know the connection between sun and its light. But we own this brain in our heads, and yet we are unable to explain the connection between the back of the brain and the front of the brain. What essentially is the back of the brain that develops in early development and the front of the brain that develops in later development. So there has to be a connection because we are using the same brain. So 3 ways to explain this. The first way is backwards. When you're an adult, the main part of our brains that we're using is the frontal areas. So it's like a conductor conducting an orchestra. You have all of these different parts of your brain doing different things. And any part of your brain can actually make a decision. But the frontal area of the brain's job is to make sure that this part of your brain that's trying to make a decision is still coordinating with another part of your brain that has relative information for that decision. But the main thing before we go any further, we want to explain the main thing of human ability, the purpose of the prefrontal cortex. The distinctive mark of human intelligence is that we have the ability of foresight. That is the main part, the main goal of all of these skills. So if the frontal area of our brain is trying to get one part of our brain to coordinate with another part so that we can get a picture, foresee, have a foresight image of what it is that needs to be done before we embark upon a decision, then we would be able to say that the frontal area of our brains did its job. So the frontal areas develop predominantly during the teen years and the early adult years. The brain actually gets fully developed probably more around 24 to 27 years old. And that's a big change from when, back in the 70s, scientists thought our brains were fully developed like at age 14. So that's a big leap. And so we've come a long way, but a lot has happened just in the last 20, 30, 40 years of neuroscientific discovery. And so we really need to incorporate that in what it is that we're understanding about what we're capable of. So as adults, we're predominantly using all of these skills of the prefrontal areas of our brains. And those depend on how the teen years develop. You always hear that teens are, still developing their ability to foresee and make decisions and hypothesize. Well, that's because they're still gaining the complete context of all of the skills that are involved in development of the prefrontal cortex. But it would help us to know, just as we learned the digestive system in school, it would help us to learn about how the brain really works and how it really operates. The main skills of the prefrontal cortex, these are abstract skills that are based on connecting pieces of information. Intuition is fundamentally the ability to connect pieces of basic and diverse information, knowledge, processes. That's what intuition does. We connect pieces of information. The skills of the frontal areas of our brain are doing just that. They are connecting pieces of information and filling in pieces of information, and if necessary, creating pieces of information that would be relative or supporting or sustainable to whatever other information that we have. So since we need to process these skills abstractly and intuitively, it actually depends on the fundamental ability of intuition. Now, the height of intuitive capability and intuitive learning acquisition is the preschool stage. Well, why is preschool stage the height of intuitive learning? Of course, if we were learning a language at the preschool stage versus learning it at the 2-year-old stage, it would be easier for us to learn that language more intuitively at the 2-year-old stage. But in terms of prefrontal development, the preschool stage is the height of intuitive learning because the most abilities that we'll ever have are actively present and simultaneously present and active as virtual, identical processes and skills of learning and development. And since they're so similar, they can hardly help but do what similar things do. They connect, just like when you connect with somebody that you meet that's very similar to you. You connect with them. And that's what those skills do. So when the fundamental skills of cognitive development can connect at the preschool stage, when the most skills are present, then they can connect. And since we're learning the most intuitively at the preschool stage, then they connect cognitively and intuitively. Now, the skills of the prefrontal cortex are advanced cognitive skills, but they are also fundamentally intuitive skills, so that they need the basic core elements of intuition and cognition. And the basic core elements of intuition and cognition are connected together during the preschool stage, when all processes of learning are fundamentally one and the same, and all of the brain is learning everything the same. So what that means in technical terms is that the brain has a neuronet, and the neuronet operates according to information that is connected together by neurotransmitters and synapses. And the majority of those connections are made during the preschool stage. So yes, if you want to know if we're each functioning on a preschool neuronet, the answer is a resounding yes. 90% of what we do, think, feel, and say is based on a preschool neuronet. So we have to really consider that. That's kind of humbling. It's actually even a bit humiliating when you consider the fact that as much as 90% of our brain develops by the time we're 5 years old. And in neuroscience, that would actually be explained as 90% of growth. But in cognitivology, we're putting growth and development as synonymous processes, because the reason why the brain grows that much is because it's making room for all of the branches, the open-ended branches of synapses and neurotransmitters that are going to be acquiring knowledge and information. So from the preschool stage up until the end of the teen years and into the early adult years, we're actually piling on and accumulating knowledge and information based on a neuronet that has been able to accommodate and just absorb as much knowledge and information as possible. But we should be able to intuitively connect that knowledge and information. And if we have learned to intuitively process open-ended and unlimited pieces of knowledge and information during the preschool stage, then we will be still capable of doing that when we get into the teen years and then when we get into the adult years. And then those open-ended processes of acquiring new patterns of knowledge and information would be much easier for us. In other words, we will have unleashed that latent 80% of untapped brain potential. So this is the end of part 1. Stay tuned, and we'll be joining you shortly for part 2. Hi, welcome back again. This is part 2. In this part, we'd like to define some of Cognitivology's definitions. We'd like to present Cognitivology's new definitions for some of the aspects of human potential. But before we get started to do that, I'd like to present an idea. If someone were to ask you, what is the connection between emotions and math, what would you say? Would you think that there's a connection? Would you say that they're disconnected? Would you be taken aback by such a question, wondering why someone would ask you something so odd? Because I've never been asked that question, but I do ask that question of other people. What is the connection, relationship between emotions and math? I would say that most people say none. Other people say, I'm clueless, never had any idea that there would be a connection. Some people vehemently rally against any idea that there's a connection between emotions and math. And then I'll ask them, for instance, say, well, how did you feel about math while you were growing up in school? And I would say 60% conservatively say they dislike math, while another 40% say that they really liked math. And then I say to them, well, okay, you just said that there was zero relationship between math and emotions, but now you just told me that you liked math or you disliked math. And those are verbs that are explaining feelings. So there is actually a connection between math and emotions. If you review our infomercial, I went into detail explaining how the fundamentals of all knowledge are based in our natural world. We get all of our knowledge and information from the natural world, and all knowledge and information is definable by the fundamental principles of math. So a preschool learning curriculum should be a natural science curriculum, modified and diversified by the fundamental principles of mathematics. And also, when we consider that cognition, because everything can be defined by math, cognition itself is also a mathematical process. But cognitive development itself, which we use to describe early learning, is also actually the formal title of math for preschoolers. Why? Because children are learning the basics of everything, which means that they're learning the basic math of everything, because everything in the universe is basically definable by the fundamental principles of math. And any scientist will tell you that the universal language is math, or the fundamental principles of math and physics. So we'd like to define for you a connection between cognition and math, since cognition is a mathematical process. Traditionally, cognition has been defined, if you go to Oxford or Webster, cognition is defined as the ability to acquire knowledge and information through our senses. Well, The human brain is hardwired for compassion and optimism. What does that mean? The human brain, we know, is designed to develop emotionally. In other words, we're born with underdeveloped brains, unlike animals who are born with fully developed brains, which is why they respond to their instincts or whatever their mother teaches them, because their neuronet of synapses and neurotransmitters are already connected together. In human development, our synapses and neurotransmitters have to be produced and then connected together. And all of this depends on emotional intelligence development in the first 3 to 5 years of life. And since cognition is a mathematical process, it is also an emotional mathematical process, or an emotional intelligence process. And so if you consider that the brain is hardwired for compassion, what is the true definition of compassion? Well, if our brains design emotionally and our brains are hardwired for compassion, then the true definition for compassion would be a value index that is attributed to every single emotion, so that every emotion can actually be a seed of ability or be treated as an ability. And if our brain, once again, is designed by emotions, then how is the proper way to define optimism? Now, most people want to define optimism as, some happy-go-lucky, positive way of thinking. That's fair. But when we consider that the human brain is designed for unlimited knowledge processing, and the brain is hardwired for compassion, which gives a value index to all emotions because our brain is designed emotionally and develops emotionally, then the proper definition for optimism should be the unlimited capacity of compassion to design synapses and neurotransmitters with open-ended structures so that our brains can acquire unlimited knowledge possibilities. So if we teach according to the rules and regulations of optimism, which is to explain the advantages and possibilities instead of the consequences and guilts of an action, then we create open-ended, unlimited knowledge possibilities. Because honestly, with the knowledge of guilt, it's limited, and guilt blocks our emotions, so it makes it impossible to really process unlimited possibilities. Optimism is a much better strategy, and it gives our eventual prefrontal cortex unlimited possibilities for processing unlimited amounts of connections. Now, we can willfully and deliberately eliminate whatever connections would be anti-conducive to any decisions that we want to make, but we should be able to look at them, have a look at them, process them, intuitively oversee them, or whatever else it is that our specific abilities will allow us to do when we have a fully developed prefrontal cortex. So if our brain is developed emotionally, if emotions are the seeds of abilities, if all emotions are treated as abilities, if the brain is hardwired for compassion and optimism and unlimited knowledge potential, then we would like to challenge the whole neuroscientific community around the world to change the traditional definition of cognition. It is over 90 years old, and the last few years of neuroscientific evidence should have surely changed the definition. The Cognitivology definition for cognition should be the emotional ability to acquire knowledge and information through and here's the big surprise too, our multi-dimensional sensory tools. So once again, the traditional definition of cognition is the ability to acquire knowledge and information through all of our senses. According to neuroscience and some of the other scientific fields that explain that there is more than just the third dimension to learn knowledge and information, and that we have other sensory perceptions and other sensory tools, then the proper definition of cognition should be the emotional ability to acquire knowledge and information through our multi-dimensional senses. And we do go into explicit detail in our formal written presentations in our books, explaining this particular definition. And essentially, in the neuroscientific community as well, there's been a lot of challenge, and I could even say struggle, to put an exact definition on the term of emotional cognition. But when you consider the new definition of cognition, it's easy to explain the definition of emotional cognition. So essentially, the basic definition, the real definition of cognition, is essentially synonymous with emotional cognition. So in the first stages of cognitive development, which are emotional or emotional cognitive development, then the true meaning of cognition and emotional cognition are one and the same. Emotional cognition would be the emotional ability to acquire knowledge and information, which is very simple and emotional in the first 3 years of learning. But the most advanced form of knowledge that we are acquiring is our ability to learn language. And language is going to be the tool, along with our senses, that is going to be used to acquire, understand, exchange, and communicate pieces of knowledge and information with other people. And that's important because, once again, the human brain is designed by emotions. Emotions depend on relationships, and relationships depend on communication, and communication depends on language. And we know that language significantly influences cognitive development. So these things all have to be synthesized together when we consider the first few years of early development, as much as 90% of brain development during the first 5 years, intuitive connectivity during the preschool stage, and the fundamental operations of the brain's hardwired system according to the virtues and core elements of compassion and optimism. So we'd like to speak more about language and how it synthesizes all of these aspects of true cognitive development and a connection between early cognitive development and later cognitive development. So stay tuned for part 3. This is the end of part 2. Thanks for tuning in. Hi, this is part 3. Somewhere in the beginning of this session, I threw a crazy notion out, and that was that eventually, ultimately, we believe that reasoning and emotioning are a process in adulthood that is exactly one and the same, that there is zero difference between emotioning and reasoning. Now, it's very hard to consider the concept of that being one and the same because it's so much of our literature and our history and our notions and everything that we've perceived over the last at least 2,000 years has cultivated all of us, probably, at least in the Western world, to understand that reasoning is a completely different process than emotions. That reasoning is a rational process and emotions are an irrational process. But emotions are subject to cognitive development, and cognitive development is a mathematical process. So reasoning is subject to emotions, and emotions are subject to reasoning. It's as simple as that. We've come to complicate so many things that we know. For instance, we think that the world is a very complicated place and full of wars and famine and all kinds of other adversities, and that these complications make it difficult for us to see how it is that we can actually change the world. But Complicated is different than our ability to have complex knowledge capabilities or complex intelligence capabilities. And it's it starts as a simple process. Cognitive development starts as a simple process and becomes a complex process. But that's different than explaining that everything's complicated. See, it's very easy to pass off early development as being some kind of trivial thing when there's all these major problems in the world. But if we're only using 20% of brain development and 90% of our brain develops within the first 5 years, and all of the things that we do in life and society around the world are based on our configurations and processes of behaving and thinking and feeling that is contained in this 20% limited development, then obviously the cure is very simple. It's to retrain the way we think and the way we treat and the way we do early development, so that early development becomes a process where we can actually perform complex intelligence capabilities that we are capable of, instead of complicated, dramatic capabilities that just make problems get more exacerbated than they already are. So the cure for the world is to understand early brain development. The cure for the world is to understand preschool development so that we understand the power of our prefrontal cortex. Now, one of the other so-called disadvantages in the neuroscientific world, or perceived disadvantages in the neuroscientific world, is that human brain development is a long, drawn-out process. So that even though we gain so much brain development within the first few years of life, the rest of it, our ability to reason and make decisions and hypothesize, this is a very long, drawn-out process. Now, evolutionarily speaking, some people see this as a disadvantage, but this is a great advantage to human cognitive development, because remember, the reasoning skills are fundamentally skills of intuition, where we are connecting pieces of knowledge and experience and information. Well, the longer we have to collect and accumulate knowledge and information from a multidimensional world, the more knowledge and information we have to connect together so that we can really make full use of our prefrontal cortex. It's a simple mathematical equation. So this is a great advantage in human cognitive development, and we need to make the best of it by learning more about our environment, which, as I explained earlier, is a multidimensional environment. But that's something that we will, as we unleash real human development in the context of really fostering preschool development the way it should be, then in the future we will be able to discover and unveil more as individuals and on societal levels about what it means to be able to process knowledge and information on a multi-dimensional scale. I'd like to take this moment to just stop and remind you that you can look up on our website to see what a basic preschool curriculum should look like. And we're also more than happy to even mail you a copy or a little chart or a demonstration about what that might be, so that you can go on from there. And we'd certainly encourage you to look into our books, especially beginning with the basis of language development, which I'm going to speak a little bit more about in just a moment. But to reiterate, the long drawn-out process of our cognitive brain development, especially the ability to reason, is a great advantage for human cognitive potential. It's never a disadvantage. The more information we accumulate, the better it's going to be for us. So, why is emotioning and reasoning really the same thing? Well, because the brain is designed by emotions, and all of our abilities are based in our emotions, and our most advanced abilities are our reasoning and computational thinking skills and decision-making skills. So ultimately, emotioning and reasoning should be one in the same. And when we actually can connect emotioning and reasoning, that is a sign that we are ready to tap into, or that we are already tapped into a much fuller spectrum of total brain development. Now, language. Where does language play into all of this? Well, we learn language intuitively. And as I mentioned in the previous section, it's the first real advanced knowledge scheme that we acquire. Language can be very, very complicated and it's tricky, but it also has the ability to incorporate creativity and represent all forms of knowledge and information. And we learn language intuitively when we're young. Well, why do we learn language intuitively? If language is the tool that we use to process all forms of knowledge and information, or language arts or communication, and that can include telepathy, for instance, but if we learn language intuitively and language represents knowledge and information, then the semantics and syntaxes of language should be designed sufficiently to represent the intuitive capacity of all of our abilities. So, if we use language to represent the knowledge of potential and possibilities, or more specifically, the knowledge of our brain's hardwired system, which is compassion and optimism, then we use language to represent the value of all feelings and the unlimited possibilities of knowledge that come from the basic cognitive processes of emotional intelligence, which are the basis of all cognitive processes. So language is important because we first learn to feel language before we learn to intellectualize in language. And that's why language is learned intuitively, because when we're still feeling language, we're already intellectualizing it. So that process of emotioning, early emotional development, and intellectualizing, they become one and the same at the preschool stage. In other words, one is overlapping the other, and they emerge together. They merge and emerge together, and that sets the stage for acquiring knowledge and information equally in emotional and intellectual context throughout our years of learning, so that when we get to the stage where the brain is processing its reasoning skills, the processing of reasoning skills depends on all the accumulated knowledge, which first was intellectual and previously to that was emotional. And within that scope of emotional intellectual learning, language was the companion of all of those cognitive processes all of along, both of our emotions and our intellectual capabilities. So both emotions must be treated as an intellectual process. Intellectual capabilities must be treated as an emotional process. So essentially, altogether, they're subject by the processes of cognitive development. And so in early development, when we're learning the basics of cognitive development and we're learning intuitively, then the proper definition for early learning should really be intuitive cognitive development. And that includes how language affects our brains and learning. So language should, of course, is learned intuitively. It connects all pieces of knowledge and information, and the semantics and syntaxes of language should include patterns and properties that represent the unlimited possibilities of knowledge, the unlimited possibilities of optimistic, endless knowledge and information, rather than patterns of knowledge that just represents limited abilities, the knowledge of guilt, the knowledge of consequences, the knowledge of impossibilities. Our language was never meant to represent these things. We should know primarily the advantages of knowledge and information, and if necessary, and secondarily, then we could know what the disadvantages of information may be, because it will be very pertinent to our safety or our health. So in that case, those things are very important. But first and foremost, we need to know the advantage of all information and how it's helpful to our truest cognitive ability processes. So this is the end of part 3. And please stay tuned in for part 4.
That was perfect. I was going to give you the...
Okay, I felt like you were going to give...
Now, I'm just trying to...
Harder my voice, I'm just explaining in a way. Hi, this is part 4, and it is also the last part of our webinar. In the beginning, we told you that we wanted to explain to you how important a preschool teacher's job is, that it is the most important job in the world. Well, the thing that we want to convey is that if 90% of the brain develops within the first 5 years of life, then what a preschool teacher is really important, what a preschool teacher does. That's just a said and done deal. Now, is it actually the most important profession in the world? Well, we could actually say that a farmer's job is the most important profession in the world, and next to that, a parent's job is the most important job in the world. And those two things would be true. But in terms of professional development in influencing the future of the world and a young generation and how they will carry out and apply their knowledge for the future of the world and design the future, then a preschool teacher's job is definitely the most important job, because a preschool teacher will help a child connect as much information as possible, both emotional intelligence and intellectual properties, in a professional setting. So in terms of professions, yes, preschool teachers' jobs are the most important in the world. So what does it mean in just basic applications of what preschool teachers need to do to just get a general idea? Well, as mentioned, the words no, not, don't, can't, and shouldn't must be eliminated from instructions and instructing children. Well, why? Because when we just negate a verb, it exempts us from instructing the child. It just says, we say, don't do that. Well, child needs to do something. What do they do? So it implies we call the knowledge of guilt, because guilt is a fake emotion. So why does it imply guilt, this fake emotion? Because guilt blocks knowledge development, and the brain is designed for unlimited knowledge potential. So if the knowledge of guilt, or a feeling that makes you just freeze or stop without being able to get instructions for doing something else, which children need because they need guidance, and children are unable to hypothesize the way adults can. So it is an adult's job to hypothesize the options and possibilities for children's emotions and abilities. And that's why our job is the most important in the world, because eventually emotions and abilities, or emotioning and reasoning, will become one and the same. So that's how we want to be able to influence the future of the world. That is why preschool teachers' jobs are the most important job in the world. So how do we start out with? Number 1, use non-negated, verbal, instructive, constructive, compassionate, optimistic language when teaching preschool children. What's the next step? Creative development, creative development, creative development. It can never be said enough. The basis for creative development can only be intuitively established during the preschool stage. And creative development is very important to every person's individually unique abilities, especially as they will apply those abilities according to their own reasoning skills in the future. And that's what gives, especially during the teen years, that's what gives teens their ability to feel unique as their prefrontal cortex is developing. That is very, very important to teenagers. We were all teenagers once upon a time, if we're adults now. So we know how important that is. In early development, during each of the stages of development, there are certain things that are taking place in the brain. They're undeniable. Most of the stages of brain development are doing specific things at that time. In other words, you have to address that development at that time. It is irretrievable otherwise. Yes, when we get to adulthood, we still have this ability for the brain to be plastic, so to speak, but the predominant ability to become plastic, to intuitively retain plasticity, is acquired and established during the years of brain development. We can never underestimate the importance of the brain development years in order for our adult brains to be plastic in terms of intuitively fulfilling all of our abilities based on the rules of compassion and optimism, which define the brain's hardwired system and which are basically consistent with the fundamental laws of physics that describe the fundamental laws of our universe. So it makes it all very harmonious. When you dig deeper into this little proverbial rabbit hole, it starts to make a lot of sense. So during the preschool stage of development, what is the brain doing? As already explained earlier, the brain is connecting its network of neurotransmitters and synapses. That's very important. The left and right side of the brains, which is developing based on the back part of the brain, which developed in the previous 3 years, this left and right side of the brain are pretty much sort of equal. But at any stages, there's always some parts that are dominating a little bit more. During the preschool stage, the part of the brain that's dominating a bit more is the right side of the brain, the intuitive side. Children have already learned language intuitively. They can basically speak at the preschool stage as eloquently as an adult can speak. But the right side of the brain that is exercising or acquiring the basic skills of intuitive feeling, emotion, and creativity, this is the side that's dominating a little bit more than the left side. And the left side deals with skills of literacy development or reading and writing skills. So a preschool curriculum should be based on natural science. Should children learn the ABCs? Of course. Do they have to write them completely, exactly, correctly? Never, until they get to at least first grade. Should they be able to recognize them, their name, their friend's name, know some of the sounds? Yes, but it should be done in a way that is modified by all of the fundamental principles of math, which is explained explicitly in both of our books. And also, of course, it should be done in conjunction with the natural science curriculum that is a representation of, a basic representation of all knowledge and information in our universe. If children are learning the basics and the fundamental math principles are being incorporated and modified and diversified while a teacher is using the wealth of basic knowledge by instructing children with non-negated verbal instructions. Now you have a synthesis of what basic preschool development should be like. So the dominating curriculum should be natural science. Literacy development has to be done more according to the laws of creative, imaginative development. And also, children have to master small motor skills. They need to be able to draw. If preschool development is being done with literacy development and reading, writing skills at the forefront, or that there are only correct answers, then there's only one way to describe this. Any school that's doing it is doing it wrong. They are ignoring the neuroscience. And anyone who says that that is the way a preschool curriculum or even a kindergarten school curriculum is supposed to be conducted, then they are plainly and simple wrong, and the science will stand behind it more than just the neuroscience. Other fields of science will definitely stand behind it too if you collect the evidence and look at the basic premises that connect the various fields of science, so that they are also relative to the most basic stages of cognitive development. So these things are important, but ultimately emotional intuitive development is the precursor. Emotional intuitive development during the first 3 years of life is the precursor to preschool development, which lays out the foundations for open-ended knowledge processing for many years before the prefrontal cortex becomes fully activated to become fully developed by the end of the early adult years. So the precursor, once again, is emotional intelligence development, then preschool development, which prepares the brain for many years of accumulating knowledge and experiences so that the prefrontal can properly develop during the teen years. And of course, all of that is synthesized once again with the brain's hardwired system for compassion and optimism, which must be conducted with language skills that support those basic virtues and characteristics of our brain's potential. So the one last thing that I'd like to touch upon, of course, is the knowledge of guilt. So what is guilt? Guilt fundamentally is a fake emotion. Why is it a fake emotion? Because it blocks knowledge processing. So why do we use the knowledge of guilt? Where did it come from? Well, that would be a long historical story, but essentially the cognitivology basic definition for guilt is a knowledge process that we acquire early in our intuitive development that forces us to relinquish ownership or sensitivity to basic emotions and impulses. And that surrendering requires us to hand over these feelings and senses to other people who then demand how it is that we use our feelings and senses. You can feel like this, never feel like that. But we need all emotions to learn. So guilt stops us from feeling certain things because the protocols of society or whatever says that this is how you should behave, this is how you should act, rather than treating all behavior impulses and emotions as abilities so that they can be synthesized and connected with our abilities then and all of our capabilities. Then all of these definitions get defined early on how our emotions are supposed to behave. And so instead of becoming seeds of abilities and knowledge and information acquisition, they become these seeds that have been limited or contained and unable to process the senses and feelings of information, which the brain, the human brain, needs to process information. We need feelings and senses to process all information. And so guilt is a fake emotion. It has zero place in real human cognitive total brain potential, especially it has zero place in intuitive processing. And once again, in coming to a close here, we do go into extreme detail to unravel the knowledge of guilt, the knowledge of consequences, and we go into extreme detail about explaining the knowledge of potential and possibilities. And of course, many of these things are redefined according to the brain's hardwired system for compassion and optimism. So most of this information would be new, and in some senses it would actually feel crude because they are so new or different from what we have been cultivated to understand, which remains consistent with the recycling of just 20% of brain potential. So once again, I'd like to thank you for tuning in to Cognitivology's webinar and the possibility of exploring going beyond the recycling of 20% of brain potential and unleashing that 80% of brain potential that has remained latent for thousands of years, for way too long. Let's finally do the job of connecting early emotional brain development and preschool brain development to prefrontal cortex, matured adult brain development. Let's fulfill that task. We can do it together, but it really is going to depend especially on preschool teachers. Preschool teachers are the ones who are going to be able to set the pace and the example for knowledge and educational reform for the future by taking now into your own hands the knowledge that we can change the way children are learning today. Then we can actually change the world tomorrow. Well, thank you. And we hope that you will look into our literature and explore more on our website. We'll be blogging in the future, and probably I'll be tweeting at some point too. Thank you. This is the end of part 4 and the entire webinar session. So long.